Hello everyone. What we're going to look at in this video is how we set up the graph required to solve a linear program graphically when we have a minimization problem. And what we should see is that the initial setup of the graph is absolutely no different between a minimization problem and a maximization problem. So this should look identical to what we've already seen in terms of setting up a maximization problems graph. Once again, we have already created this mathematical model in a previous video, so please, if you do not understand where this model is coming from or this linear program is coming from, consult the prior video to figure out how we came up with these values and how we set up this mathematical model. But from here, what I'm going to be doing is using this model in order to create the graph for the situation. Not explaining where these came from, but explaining how I'm going to set up the graph itself. So as we saw with the maximization problem, let's begin with an initial graph. And again, it does not matter what I set to be my y-axis variable and what I set to be my x-axis variable. The only difference, if I reverse those, is the initial graph will look slightly different because it will be a mirrored image in a way of what this one will be. But if I follow this through to completion and solve the model, the final answer would be identical, no matter which way I set it up. But as I stated in the previous video, please pay careful attention to the way that I've set them up when we're doing assignments or tests, because typically I will have already associated one of the variables to be the y-axis variable and one of the variables to be the x-axis variable. So unless you set it up in the same way that I did, the graph may look a little different, but again, final solution should be the exact same. So what we've seen already is as we go to set up the initial graph, is really all we're trying to get on here is the graphical representation of the constraints. And if I look back at my constraints, we had the phosphate, the nitrate, the ammonium constraint. And with all of those constraints in this case, they all had to be greater than or equal to. Well, once again, as we did see in the previous video, we will not care whether those are greater than or equal to, less than or equal to, greater than, less than, anything. When we set up the initial graph, we are always going to make those equations where we're going to replace temporarily. We'll deal with the greater than or less than part in a future video, but for now, temporarily, we are simply going to set that to be equal to whatever that right-hand side value is. So here I'm creating my first constraint, which in this case was I believe the phosphate constraint. 5A plus 3B had to be greater than or equal to 45. But again, just setting that equal to 45 for now. And the easiest way to do this is to simply get 2 points, right? Any line, and these are all lines, right? That's the whole concept of linear programming. Everything is lines. So as we set this up, I just need 2 points. And in my opinion, the easiest 2 points are to find the point on the y-axis and the point on the x-axis. Well, to find the point on the y-axis in this case, so on the y-axis would be where variable a is equal to 0. So if I sub in 0 into that equation, so 5 times 0 would be 0, I'd be left with 3b is equal to 45, or b is equal to 45 divided by 3, b would be equal to 15. And now I have my first point that I can put on this graph, a point of 0, 15. I would repeat that process to get the x-axis point. And in order to do that, I would simply sub in 0 for my b variable now. So subbing in 0 for b, I end up with 5a is equal to 45. A would be 45 divided by 5, or a is equal to 9. And I now have my second point for the equation of this line. And I just connect those two values. I have now graph constraint 1. Now I would continue that process. I now have to do that for each and every single other constraint. Well, here I have 2 further constraints. So I will repeat it 2 more times. Looking at constraint 2, the nitrate constraint, which again was initially 2A plus 3B is greater than or equal to 36, but setting it just to be equal to 36 for now. Subbing in 0 for A, we end up with 3B is equal to 36, B is equal to 36 divided by 3, or B is equal to 12. Graphing the point 0, 12. Subbing in 0 for B, A would be 36 divided by 2, or 18. And now graphing the point 18, 0. Connecting those 2 dots. We have now graphed our second constraint. I now repeat that one final time in order to graph the third constraint, the ammonium constraint. Again, ignoring the inequality temporarily. Subbing in 0 for A, ending up with B is equal to 40 divided by 5, or 8. Plotting that point on the graph. Then subbing in 0 for B, ending up with the point A is equal to 40 divided by 2, or A is equal to 20. Plotting the point 20, 0. And now I have the third constraint graphed. And we are at the point where we can go about dealing with the actual solving of the problem. That will be covered in future short videos. For now, this is as far as we're going with this question. Please stay tuned for future videos. And as always, contact me as soon as we are having any difficulties whatsoever. Thank you very much.